Now our next discussion will be dimensions, dimensional equations, dimensional formula of physical quantities. So dimensional formula is almost same as the units of a physical quantity. The dimensional formula, it is also like unit, but here we represent the base units in terms of symbols. So I will mention all the symbols for different base units. So in symbolic form, we represent the base units in dimensional formula. So dimensional formula is derived from the unit of any physical quantity in symbolic form. So I will write down the symbols used in dimensional formula for different base units. So in dimensional formula, length, we know the unit of length is meter. In dimensional formula, its symbol is L. Similarly, mass, we know the unit of mass, SI unit of mass is kilogram. In dimensional formula, it is represented by M. Next, current, we know its symbol is MA, that is ampere, and it is represented by I, and sometimes it is also represented by A itself. Next, Kelvin, temperature. Temperature is represented by Kelvin in SI units, and in its dimensional symbol is theta. Next, candela. CD symbol, candela for luminous intensity. Luminous intensity, its unit is CD, and its symbol is J in dimensional formula. And the last is mole, that is amount of substance. Its SI unit is mole and its symbol is N. So these are the 7 base units in SI system, and these are the units symbols which are approved in SI system. For dimensional formula, when we write dimensional formula of any physical quantity, we just replace these symbols of unit with these standard symbols of dimensions. Length is represented by L, mass is represented by M, time by T, current by I or A, temperature by theta, candela, that is luminous intensity, by J, and amount of substance, that is mole, is represented by N. So the basic purpose of dimensional formula is to standardize the representation of unit. So we know there are different system of units, CGS system, FPS system, SI system, and for any physical quantity you will have different representation in terms of units in different systems. For example, for force in SI system it is Newton, in CGS system it is dyne. So Newton will be represented at kilogram meter per second square, and dyne will be represented at gram centimeter per second square. In FPS system it will be foot pound per second square. So you will have different units in different system of units. To standardize the representation of unit in symbolic form, irrespective of system of units, we use dimensional formula. Dimensional formula for a particular unit is independent from the system of units. It doesn't consider system of units. So different system will have different units, but dimensional formula is independent from any unit system, and it is unique based on these standard symbols for any physical quantity. So what is the dimension? Dimension of a physical quantity. So when we represent a physical quantity in terms of units, base units, then dimension is the power of base units. When we use these powers with dimensional symbols, as we have discussed earlier, for different units, that representation is called dimensional formula of a physical quantity. For example, force. We know the equation of force, F is equal to m into A. So in SI system, its unit will be kilogram meter per second square. Now, as replace these base units with their standard symbols, so it can be represented as m L by T square. So these powers on base unit symbol to represent the dimensional formula of a physical quantity are called dimensions. So here we can say force has, dimension of force is 1 for mass, similarly 1 for length, and -2 for time. So here we will say force, that is the physical quantity, has dimension 1 in mass, dimension 1 in length, and dimension -2 in time. So these powers to which the base quantities have to be raised to represent the unit of a particular physical quantity are called dimensions in different base units. So dimensions are powers. In simple term, dimensions are powers to which base quantities are raised. So these dimensions you can find here also. For mass it is 1, for length it is 1, and for second it is -2. Same dimension will be here also. So dimensional formula is nothing but, it is more or less like unit. It is the symbolic representation of a unit. Symbolic representation that is independent from all system of units, irrespective it is SI unit system, it is FPS, it is CGS, that doesn't matter. Dimensional formula is independent from the unit, but it has been derived from the unit actually. It has been derived from the unit. To write the dimensional formula, write the unit of a physical quantity. You can write unit in any system, not necessarily in SI system. You can write unit in CGS system. CGS system, the unit of force is gram centimeter per second square, and in FPS system it is pound foot per second square. So in all these system, different units are used, but dimensional formula will be same, because these symbols used in dimensional formula are standard. They are unique, irrespective of the system of units, whether it is SI system, whether it is CGS system, or it is FPS system. Irrespective of the system of units, the dimensional formula is unique, because these symbols are standard symbols. Now the next thing in dimensional formula is that the symbols used in dimensional formula, they obeys rules of algebra. As these symbols which are used in unit, they also obeys rules of algebra. That is, kilogram into kilogram, we write it kilogram square. Meter into meter, we write it meter square. Similarly, these symbols, that is m into m, you can write it m square. L square into L, you can write it L cube. M square divided by m, you can write it m. So these symbols, like the symbols of unit, these symbols in dimensional formula, they also obeys algebra, rules of algebra, multiplication, divide, division, and other rules of algebra. So to make the problem simple, you just think that this dimensional formula is nothing but it is the standard unit. It is the standard unit in symbolic form. Irrespective of the system of units, it's a representation of unit in symbolic form. So like unit, it will also obey, these symbols will also obey rules of algebra, as these symbols of units obeys rules of algebra. Likewise, these dimensional symbol also obeys rules of algebra, and most of the application of dimensional formula and dimensional equation are same as applications of units. But as these are the standard representation of unit in symbolic form, so it is always easy to carry out the application of dimensional formula instead of units, symbols of units, kilogram, meter, gram, second, pound. These are the standard representation. So otherwise, whatever derivations, whatever problems you can solve with dimensional formula, you can solve all those problems with the help of units itself. But they are not universally represented in a uniform way. Different units in different system. So dimensional formula it is quite different in terms of representation, because its representation is independent from the system of units. Otherwise, application of dimensional formula are same as the application of units, and all techniques used in a dimensional formula will be same as with the units, because it is nothing but the representation of unit in symbolic form. That's it. So now we will discuss how dimensional formula of a unit is represented. So that when we write force is equal to m into a, when we write force like this inside the bracket, that means we are writing the dimensional formula of force. And to derive the dimensional formula, the very simple technique is that just find the unit of that physical quantity in any system, SI system, CGS system, FPS system, whatever system you can find the unit and replace these symbols of unit from respective symbols of dimensional formula. For example, kilogram, replace the kilogram with m. Length, replace the meter from L. Second, replace the second in unit by T, like this. After replacing all those units, you will get dimensional formula of that physical quantity. So we will just take a very simple example to find the dimensional formula of force. So the first step is write down the unit of force. M into a, m is kilogram, and unit of acceleration is meter per second square. So write the unit of force in terms of base unit. That is, divide these expression till all the expressions are divided in terms of base units. They cannot be further divided. So here we have divided this expression of force in terms of base units. This kilogram, meter and second cannot be further divided in other units. After dividing in base units, replace those base unit by the symbols of dimensional formula, which I have written earlier. Symbols used in dimensional formula for length, mass, time, candela, Kelvin, etc. Replace those symbols by units. So kilogram is the unit of mass, so replace kilogram by m. Meter is the unit of length, so replace meter by L. Time, second is the unit of time, so replace second by T square. Now it can be written as m l t minus 2. As the dimensional formula is always represented by a bracket, so we can say dimensional formula of f is bracket m l t minus 2. So these dimensional equations are always represented with the help of brackets. So this is the dimensional formula of f, that is force. Dimensions of force in mass is 1, in length is 1, in time minus 2. We can say dimensions of force is 1 in mass, 1 in length, and minus 2 in time. So that is how dimensional formula is expressed in terms of symbolic representations with their respective dimensions as the powers of symbols of base units. These powers are dimensions. 1, 1, minus 2, these are dimensions of force in meter, length and time. And MLT, these are just symbols. You can see, you can find this unit from dimensional formula. To find the units, just replace M by kilogram if you want to find in SI system. Then L by meter and T by second minus 2. So this is the unit in SI system. You want to unit in CGS system, replace M by gram, L by centimeter, T by second is minus 2. This is in CGS system. You want to find the unit in FPS system, replace M by pound, L by foot and T by second. That is FPS system. So this is SI system, this is CGS system, this is FPS system. So after finding the dimensional formula, you can easily find unit in any system of units very easily by replacing these symbols, standard symbols of length, mass, time by units, base units in the respective system of units, that is CGS system, FPS system, SI system. So after finding dimension formula, you can find unit in any system, or you can find, after finding unit in any system, you can find dimensional formula. With this much of discussion, you will easily conclude that dimensional formula is nothing but it is symbolic independent representation of a unit. Symbolic means symbols are used instead of units, base unit, that is gram, mass, pound, etc. Symbols are used. So these symbols make dimensional formula independent from the system of unit, first. And second, dimensional formula can be derived after finding unit of a physical quantity in any system of units. That is, either find in SI system, CGS system, FPS system, any system, you just find the unit of that physical quantity by its formula. After finding unit, you can easily find the dimensional formula. So we will take some more simple examples how to find the dimensions. So as we have found the dimensions of force, now we will let us find the dimension of torque. So first step, write down the formula. T is equal to F into distance R. Now you have to break down these physical quantities till we get base quantities, till we cannot further divide those quantities. So dimension of this distance, that is R, is meter. Now force is mass into acceleration, m into a. and this is meter. Again m into a, m is unit of mass is kilogram, unit of acceleration is meter per second square into meter. So in terms of base unit, we have found the unit of torque in terms of base unit kilogram, meter square, second square. Just replace these base units with their respective symbols used in dimensional formula. Kilogram, it is the unit of mass, its symbol is m. Meter is the unit of length, its symbol is L. Second is the unit of time and its symbol is T. So it can be written as m L square T minus 2. And when we write down the dimension, we represent with bracket. So dimension of torque is written as m L square T minus 2. So this is the basic method to find the dimensions. Just write down the formula. Based on the formula, break the physical quantities till base quantities are achieved. Base units are achieved. Kilogram, meter, second, Kelvin, candela, etc. Base units. They cannot be further divided. Replace base units from symbols used in dimensional formula. And as the symbols used in dimensional formula obeys rules of algebra as symbols of base unit, because dimensional formula is symbolic representation of unit. It's nothing but symbolic representation. So these M, L, T, they all obeys rules of algebra as they are obeyed by kilogram, meter, second, etc. in representation of unit. Similarly, dimensional symbols also use rules of algebra like unit symbol. Now we will discuss about some applications of dimensional analysis, dimensional formula. The major applications of dimensional formula are same as the applications of units. Directly from unit of any physical quantity, we can carry out all operations which we carry out by using dimensional formula. The difference is only that dimensional formula is standard representation. Otherwise, dimensional formula you can treat as unit of a physical quantity in symbolic form. So its application is not different from application of units itself. Unit of any physical quantity can be treated same way as we treat dimensional formula of a physical quantity. Both are exactly same. Only difference is that dimensional formula is symbolic representation. That's it. Otherwise, all applications of dimensional analysis are same as applications of units of a physical quantity. So we will discuss one by one. First is dimensional formula. You can convert unit from one system to another system. We have earlier discussed how to convert the unit from CGS to SI system to FPS system. We have earlier also discussed without dimensional analysis. In dimensional analysis also, it helps to convert unit from one system to other system. We will discuss. So let us say 15 Newton force. We want to convert this force in CGS system, that is in dyne. Basic equation which is used to convert unit by dimensional analysis is N1 U1 is equal to N2 U2. N1 U1 is nothing but when we represent a unit, a physical quantity, we have discussed earlier that this quantity has two terms. Its representation has two terms. one is numerical value and second is unit. For example, force 15 Newton. So this 15 is N1 and this Newton is U1, that is unit in a particular system of unit, which is SI system here. So N1 is the numerical value and U1 is unit in a physical system. So when we convert unit from one system to other system, this product remains constant. If it is in SI system, in CGS system, or in, it can be written as N3 U3. Suppose this is SI system, this is CGS system, and this is FPS system. So in all systems, this formula will be valid. When you change the unit, that is U, this numerical value will change according to the unit. So this is the basic formula. Here 15 Newton, N1 is 15 and U1 is Newton. Here you can find N2 and U2 will be 9. And here U3 will be pounder, that is unit of force, and here U1 is Newton. So this N1, you can say U1 is N, that is Newton, U2 is dyne in CGS system, and U3 is pounder in FPS system. All these three are unit of force. So first of all, we will find dimensional formula of force. So force is equal to mass into acceleration. Unit of mass kilogram meter per second square, that is acceleration. So its dimensional formula of force is mLT minus 2. That is the dimensional formula. Now this dimensional formula is independent from the system of unit. It has been derived from, we have derived here from SI unit, but it doesn't depend on type of unit. It can be derived from CGS system also. It will be same. Now this dimensional formula, now we will apply this dimensional formula to convert 15 Newton force in CGS system. So N1 U1 is equal to N2 U2. So here U1 is U1 left, U1 is M1 L1 T1. In system U1 we represent length as M1, mass as M1, length as L1 and time as T1. In U2, system mass is represented as M2, length is represented as L2 and time is represented as T2, that is CGS system. So here N1 15 into M. Write down the dimensional formula in SI system. In SI system, this is, we have assumed SI system, this we have assumed CGS system. This representation we have assumed in CGS system. So from this formula, SI system M1 L1 T1 minus 2. M1 L1 T1 are symbols in SI system. Let numerical value in CGS system, it is N2, and U2 is CGS system, in U2 is M2 L2 T2 for mass, length and time. We know dimensional formula is same for all units, so it can be written as M2 L2 T2 minus 2. So here you can say N2, that is numerical value in CGS system, is equal to 15 by into M1 by M2, L1 by L2, T1 by T minus 2. As they obey rules of algebra, so here you know M1 is meter and M2 is centimeter. So we can write as meter, M1 is meter and M2 is centimeter, because M2 is unit in CGS system and M1 is unit in SI system. So this can be written as 15, 1 meter is 100 centimeter, we know 100 into L1 is length, L1 is in meter and L2 is in centimeter. Sorry, we have done mistake. M1 is the mass. So M1 is kilogram and M2 is gram. So this will be 1000. 1 kilogram is equal to, it can be written as 1000 because M1 kilogram and M2 is gram. So M1 kilogram is equal to 1000 gram. Similarly, L1 is meter and L2 is centimeter. So you can say L1 is equal to 100 L2. 1 meter is equal to 100 centimeter. So it will be 100. Now T1 and T2, these both are second, because in both system unit of time is second. So it will be 1. So this can be written as, so I can write as N2 is equal to 15 into 10 to power 5. That is the value of N2. So I can write as 15 Newton force. 15 Newton force as 15 into 10 to power 5 dyne. So that is the one way to find the numerical value in different units, in different system of units, by using dimensional formula. So we have converted 15 Newton force from SI unit to CGS system, that is 15 into 10 to power 5 dyne, by dimensional analysis. We have earlier marked it as N1 and Newton as U1, and now this whole numerical value is N2 and this is U2. Here N3, this is N3 numerical value in foot pound second system, and its poundal, that is unit of force in FPS system, will be U3. So you can write as N2 U2 is equal to N3 U3. N2 is 15 into 10 to power 5. U2 M L T minus 2. So here let it was M2 L2 T2. In CGS system, as we have marked as unit of mass, length and time as M2 L2 T2. So this is the representation of unit in CGS system. Now N3, let N3 is the numerical value of unit in FPS system, and poundal is the unit of force in FPS system. So it can be written as M3 L3 T3 to power minus 2, where this M3 L3 T3, these are in FPS system. M3 is, that is pound, L3 is length, that is foot, T3 is time, that is second. Similarly here M2 is mass, that is gram, it is CGS system. L2 is length, that is centimeter, and T2 is time, that is second. Second is same in both system of units. So this is in CGS system. So we will find what is the numerical value, what this numerical value will be in FPS system. So this is CGS system, this is FPS system, and we are using this formula to find the unit. So we can say N3 is equal to 15 into 10 to power 5 M2 by M3 L2 by L3 T2 by T3 minus 2. So this is second in both system of units. Unit of time is second. So it can be cancelled. This ratio will be 1. M2 is gram in CGS system and M3 is pound in FPS system. So 1 gram is 0.002 pound. So we can write it as M2 by M3 as 0.0022. 1 centimeter is equal to, 1 gram is equal to 0.0022 pound. So this ratio, that is gram by pound. Gram by pound is 0.0022. Similarly, this is ratio of centimeter and feet. L2 is centimeter in CGS system and L3 is foot in FPS system. So 1 centimeter is 0.0328. So the ratio of centimeter by foot is 0.0328. So if you will multiply this and this, you will get this figure 0.000072. So this can be written as 15 into 1, 2, 3, 4, 5, 7.21, and this can be written as 108.15. So we can say N3 is equal to 108.15. So N3 is equal to 108.15. That is, N3 is what? N3 is numerical value in poundal. Numerical value of 15 Newton or 15 into 10 to power 5 dyne in poundal, that is in FPS system. So N3 we have calculated as 108.15 poundal. So it will be, so we can write it as so we can say in SI system N1 is equal to 15 Newton. In CGS system, N2 is equal to 15 into 10 to power 5 dyne, and in FPS system N3 is equal to 108.15 poundal. N1, N2, N3. These are the numerical value in SI, CGS and FPS system. Similarly, U1 was unit in SI system, U2 was unit in CGS system, and U3 was unit in FPS system. So for conversion of units from one system to other unit system, you can use this N1 U1 is equal to N2 U2 is equal to N3 U3 is equal to N4 U4 and so on in different systems. First system of unit, second system of unit, third system of unit, fourth system of unit, and number of systems. You can use the same formula to convert the units from one system to other system by dimensional analysis. So this first application of dimensional analysis, that is conversion of units from one system to other system, we have discussed. This you can convert directly from one system to other system, as we have discussed earlier, without dimensional analysis, by just putting the values of base unit from one system to other system. For example, put the kilogram in terms of gram for conversion from SI to CGS, that is 1 kilogram 1000 gram. Put meter as 100 centimeter from SI to CGS. We have discussed this method also. That is very direct method for conversion of units from one system to other system. With the help of dimensional analysis, we have discussed same problem, conversion of Newton, dyne and pounder. Same conversion we have discussed without dimensional analysis, directly by putting the values of one unit in terms of other unit, that is kilogram in terms of gram, meter in terms of centimeter, centimeter in terms of foot from CGS to FPS. Directly you can put the values, then also you can convert the units. Now second application of dimensional analysis is to find correctness of a physical equation, whether a physical equation is correct or not. That also you can find by dimensional analysis, or by simply finding the units also you can find whether the equation is correct or not correct. The basic principle for this application is principle of homogeneity. So if two quantities have same units or same dimensional formula, only then they can be added or subtracted, or they can be equated. Otherwise they cannot be compared. They must have same unit or dimensional formula. This principle is called principle of homogeneity. For example, Newton's law of motion, S is equal to ut plus half at square. Here, principle of homogeneity says that only those physical quantity can be equated, added or subtracted which have same dimensional formula or same unit. So according to principle unit of homogeneity, S is equated with ut and ut is added with at square. Half, but for dimensional point of view, half is constant, doesn't matter. So based on the principle of homogeneity, these two quantities are being added, so they will have same dimension or unit. So unit of S, that is displacement, unit of ut, unit of at will be same as per the principle of homogeneity. So first, a unit of S, that is meter, its dimensional formula you can write as L, that symbol of length. Second, ut, that is velocity into time. ut, that is velocity into time. Velocity is meter per second, into time is second, so it is also meter. So dimension of ut is L. Third term, that is at square, acceleration into time square. This unit of this will be, acceleration is meter per second square, time is second square, this unit is also meter, and dimensional formula of at square is also L. So here you can see units of S, ut and at square, that is S, ut and at square are same, that is meter, meter, or unit of length. We have found unit in SI system, but it can be found in any system. Similarly, their dimensional formula is L for S, ut and at square. S, ut and at square, dimensional formula of every term is L. As this every term has same dimensional formula, hence principle of homogeneity is met here. Hence this equation is dimensionally correct. An equation is dimensionally correct only when it obeys the principle of homogeneity. That is, the equated term have same dimension and the term which are being added or subtracted have same dimension. Here we see every term has dimension L. Hence the dimension of every term is same. So principle of homogeneity is being satisfied here. Hence the equation is dimensionally correct. So that is the second application of dimensional analysis. And the last application of dimensional analysis is to derive the formula. It can also be used to derive the formula. So we will discuss very simple example here. For example, the time period of a simple pendulum depends on length of pendulum, acceleration due to gravity. We know this. So we can say T is proportional to length of pendulum and T is proportional to acceleration due to gravity. So time period of a pendulum depends on length of pendulum and it depends on acceleration due to gravity. So we can use dimensional analysis to derive the equation of this to derive the equation between time period and these two variables. So let T is proportional to L, that is length of pendulum, to power A, and G, that is acceleration due to gravity, to power B. So we can write it as T is equal to a constant into length, acceleration due to gravity, having powers A and B. Now as per the principle of homogeneity, both these terms which are being equated will have same dimensional formula. So dimension of time period, we will represent time period by Tp to avoid the confusion. Tp. So the dimension of time period is in terms of, it is a its unit is second, hence its dimension will be T. Similarly, dimension of length, we know it is L. Dimension of G, it is meter per second square, that is L T minus 2. These are the dimension of each term. So we will compare now the dimensions of both sides, that is dimension of time period, which is T. We can write dimension of time period, which is T, as in terms of MLT, M power 0, L to power 0 and T. This way also we can write dimension of time period. And this is equal to constant dimension of length L, L to power A. Dimension of G, that is LT minus 2, LT minus 2 to power B. This can be written as K L to power A plus 1, T to power, sorry, L to power A plus B and T to power minus 2B. Here it is L, M, L, T. Because they obey the rules of algebra, which we have earlier discussed. These K, L, M, T, they all obey rules of algebra. So here by rules of algebra, we have written the powers of L as L to power A plus L to power B. That is L to power A plus B. power of t, t to power minus 2b. So by comparing the powers of these symbols, we can write L. For L, a plus b is equal to 0. For t, minus 2b is equal to 1. From this equation, b is equal to minus 1 by 2, and from this equation, a will be plus 1 by 2. Now we can put these values of a and b in this equation. So time period Tp can be written as constant L to power a is half, into g to power b, that is minus half. So this can be written as k L by under root L by g. By experiment, we all know that by experiment k is 2 pi. So the formula is t is equal to 2 pi under root L by g. So this is the dimensional analysis which can be used to derive the formula of a physical quantity which depends on some other quantity. Here we use principle of homogeneity, that is, the dimensions of the term which are being equated will be same, or the dimension of the term which are being added or subtracted will be same. That is the principle of homogeneity. So this was very simple example to find the equation, desired equation, with the help of dimensional analysis. So there are limitations of dimensional analysis. So we will discuss one by one the limitations of dimensional analysis. First limitation is that the dimension of a unit is unique, but if the dimensional formula of a unit is given, that dimensional formula is not unique for a particular unit. Again and again, you just listen it. For a particular unit, dimensional formula is unique. You can find dimensional formula for any physical quantity. But when a dimensional formula is given, then it is not necessarily, it cannot be pinpointed what unit you are talking about, because more than one unit may have same dimensional formula. More than one unit. For example, frequency. Frequency is a physical quantity. Unit is per second. Unit is per second, and its dimensional formula is t to power minus 1. Another is RPM. Revolution per minute. Angular velocity, you can say. That is radian per second. Its unit is radian per second. Its dimensional formula is also minus t, t to power minus 1. So we can say for any unit frequency, here frequency and revolution per angular velocity, two different physical quantities are there. Both have same dimensional formula. So if the dimensional formula for any quantity is given, then you cannot predict the nature of physical quantity, because more than one quantities may have same dimensional formula. So for a quantity, dimensional formula is unique, but a unique dimensional formula cannot be fixed for a given quantity. That is, more than one quantities may have same dimensional formula. So dimensional formula doesn't tell us the type of physical quantity, correctly the type of physical quantity, because there can be more than one physical quantities for a given dimensional formula. Another limitation of dimensional formula is that in various equations we use numerical constants which are dimensionless. So the numerical constant which are dimensionless cannot be deduced based on dimensional analysis. For example, we have derived t is equal to 2 pi under root L by G. That formula we have derived. But this dimensional constant, that is 2 pi, could not be derived based on dimensional analysis because it is a dimensionless constant. It can be derived by other theoretical method or by experimental method, but by dimensional method this 2 pi cannot be derived in this equation. So that is the limitation of dimensional analysis about dimensionless constants in a equation. Another limitation of dimensional analysis is that the derivation of formula, the formula which are derived by dimensional analysis, can only be used for multiplication and division type equations. That is, dimensional analysis can only be used for multiplication or divisional type of expressions like a b by c, like this multiplication of a b by c. This type of physical equations can be derived by dimensional analysis, but equations like ab plus c by 2, this cannot be derived by dimensional analysis. For example, equation like s is equal to ut plus half at square, this we cannot derive by dimensional analysis. By dimensional analysis we can only derive equations like s is equal to half at square, which are only multiple type, multiplication or division type expressions. Only those can be derived. But this, where we are using plus or minus, those type of equations cannot be derived based on dimensional analysis. Similar to this, the method of dimension and dimensional analysis cannot be applied to derive the formula which uses trigonometric functions, logarithmic functions and other functions where the powers are usually dimensionless. For example, sin omega t. In this expression, omega t is a dimensionless expression. So the functions which uses trigonometric and logarithmic functions, those type of relations of physical quantities cannot be derived based on dimensional analysis because these are dimensionless. These terms are dimensionless terms, so they cannot be compared actually. So another property of dimensional analysis is that, so I just remembered here dimensionless numbers, expressions. All expressions which are used in trigonometric functions, logarithmic functions, they are all dimensionless expressions. For example, log e to power fx, log fx, logarithmic function, sin fx, all these functions, the functions used in these expressions like sine, exponent function, logarithmic function, these all functions are dimensionless functions because pure numbers are used before log, exponent and sine, cos, tan, etc. Pure numbers are used. Hence, the functions which are written in front of these sine, log, etc., they are all dimensionless functions. They are always dimensionless functions. So whenever you are finding the dimension of a physical equation having sine, trigonometric function or logarithmic functions, so just take those terms, trigonometric terms, logarithmic terms, as dimensionless terms because they are pure numbers. So another drawback of this dimensional analysis is that after knowing the dimension of a physical quantity, we cannot predict whether this quantity is vector quantity or it is a scalar quantity. Dimensional formula cannot give any hint or idea about its nature, that is vector or scalar quantity. For example, velocity we know is a vector quantity. Its dimension is also LT minus 1, and speed, it is a scalar quantity, and the dimension of speed is also LT minus 1. Velocity is a vector quantity, its dimension is LT minus 1, and speed is a scalar quantity, its dimension is LT minus 1. So both vector and scalar quantity have same dimension, same dimensional formula. So by seeing the dimensional formula LT minus 1, we cannot say whether we are talking about velocity or we are talking about speed, or we can't say whether we are talking about vector quantity or scalar quantity associated with that dimensional formula.